Welcome to the data structure series. This is the continuation session after creation of nodes in a singly linked list. We are going to implement the operation insertion into a singly linked list. So insertion can be done at beginning, at the end, or at a specified position. I mean insertion in the middle. So let us understand insertion in the beginning. So I appreciate you to look into my previous video of creation and then come for insertion operation. So I assume that the linked list contains nodes 1, 2 and 3. Now you have to insert at the beginning. Create the node and read the data. Say for example, you have created the node and read the data. So this is the new node that you have created. We have understood in creation portion that head always points to the first node in the linked list. Okay, done. Say for example, first node's address is 1000. That is the value of the head. So new nodes next is equal to head. So that address is written in the next part here. Okay, so after writing, it means that there is a link between the node 4 and node 1, and head is equal to new node, means head points to the new node. Fine, this is the logic of insertion at the beginning. Done. It is that simple. Let us understand the code portion. The code for insert at the beginning is you create the node, you get the data of the node, and you say new nodes next is equal to head, and now head points to the new node. So let us understand better insert at the beginning with a visual. So for example, my linked list contains 10, 20 and 30. Look, head is pointing to the first node 10 and 30 is the last node. Okay, so now I have to insert, say for example, 5. Okay, so this is the node 5 that has to be inserted at the beginning, right? So how should I insert the 5 at the beginning? Yes, this is my logic. So I say new nodes next is equal to head. So look, this is the new nodes next is equal to head, and now head is pointing to the new node. So insertion at beginning is that simple. We can finish it in order of one time. Next is insert at the end of the linked list. To insert at the end of the linked list, you have to traverse the linked list from the start to the end. So you create the node, you read the data. Unlike insert at the beginning, you should do make the next of the new node point to null, because this is insert at end of the linked list. So this is going to be the last node. If head is null, make head point to the new node, means that this is the only node in the linked list. Else, okay, so else what happens? Use temp, as we have seen already in the previous session, use temp to traverse to the end of the linked list. So this is the condition, to traverse to the end of the linked list and make the created new node the last node of the linked list. So how should I write my program? The program first creates the node and then reads the data, makes the next of the node null. If head is equal to null, make head point to the new node. Else traverse to the end of the list using temp and then make the new node the last node. We'll understand how to do this with a visual. Initially, my linked list has nodes 5, 10, 20 and 30. Okay, so now I should enter some data for the node, and then I should maybe insert this node at the end of the linked list. What is the data of the node that I have entered? See, the node is 40 and I have made the next of the node as null. Okay, so after creation of this node, what should I do? I should use my temp. Yes, I am using my temp to traverse to the end of the linked list. So initially 30 was having null. So now what happens? I traverse to the end of the linked list and I try to make the new node 40 the last node. So how am I making the new node 40 the last node? Temps next. So this is temps next. Make the temps next equal to the new node. So look, the address of 40. So what could be address of 40 here? Maybe the address of 40 is 4000. That is written in the next of 30. So next is insert at the middle. So insert at the middle also requires a certain bit of traversal. So insert at the end is order of n times, because you need to traverse n number of nodes to find out the last of the linked list. So insert at the middle also runs in order of n time. So let's learn the algorithm. So you read the position, which position you have to insert, and then create the node and read the data. If position is equal to 1, it means that you are inserting at the beginning of the linked list. Else, again, use the same logic. So you use my temp to traverse to that particular position and insert in that particular position. That's it. That's it, the algorithm of insert at middle, right? So how should I write the code? First, get the position from the user, do the malloc, and then read your data. If position is equal to 1, and then you are inserting at the beginning. If position is not equal to 1, again use temp, use the for loops. For loop runs till position -1. So until that position, move to that particular position using temp and then insert that particular node at that position. We will understand how to insert. Initially, my structure is this: 5, 10, 20, 30 and 40. So say for example, I have to insert 25 in between 20 and 30. So the position is 4. So the loop runs for 3 times. Okay. So I have created a node called 25, and then I'm going to insert 25 in between 20 and 30. So what is my logic? My temp points to head. I run the loop until the position. I have found the position, right? So now what I do? Now I make the new nodes next. So what is new nodes next? So this is the new nodes next. See, the new nodes next is now temps next. So temps next is 3000. Fine, done. Okay. And then what happens? Temps next. Okay. So temps next is what? See, 20 is next, is pointing to the new node. So the link between 20 and 30 is broken. After 20, now there is a new node called 25. 25 links to 30. So this is how I insert at middle. So we have finished insertion at the beginning, insertion at the end, and insertion at the middle. Any doubts, post it in the comment section. I'll be happy to explain. Thank you. Happy learning. Stay connected for deletion operation.